Okay, let's dive into this. You know that feeling when you're standing over the toaster, vigorously scraping those blackened, charred bits off your morning slice of bread? Yeah, you are definitely not alone. It's one of those deeply ingrained habits that almost feels like a bizarre kitchen ritual, like eating a piece of literal charcoal is just a totally normal Tuesday morning activity. But today, in this explainer, we're going to look at the actual hard science behind that burnt food. We're separating the childhood myths we've all been told from the stark scientific reality of what actually happens when we overcook our meals. So, ask yourself, why do we actually scrape burnt toast? I mean, for most of us, it's just a behavior we picked up directly from our parents when we were kids, right? They told us the burnt parts were bad for us, and we just kind of went with it. It feels almost like a superstition, like avoiding cracks in the sidewalk. We do it without really questioning the underlying mechanics of it at all. But as it turns out, when it comes to removing those burnt bits of food, our parents might have actually been onto something highly scientific, even if they didn't know the exact chemistry behind the scenes. Because the real story actually kicks off at a very specific temperature, exactly 120 degrees Celsius. Back in 2002, scientists at the University of Stockholm made this massive discovery. They found that when we take certain common foods, and we're talking about things we eat every single day like potatoes, bread, and biscuits, and we heat them above this exact threshold of 120 degrees Celsius, it triggers a very specific, hidden chemical reaction.
And that reaction creates our main culprit, acrylamide. This is the true villain of the story today. Acrylamide is a chemical substance that just naturally forms in these foods the second they cross that high-heat cooking threshold. It's not some artificial additive, it is a direct byproduct of the cooking process itself. And let me tell you, the scientific community is highly concerned about it, because acrylamide is thought to be dangerous to humans in a few very significant ways.
Section 1. The real danger, neurotoxicity. Now, here is the major twist. While everyone just automatically assumes burnt food equals cancer, the absolute, scientifically certain danger of acrylamide, like the thing researchers know for an absolute fact happens, is actually neurotoxicity. Consuming this chemical can negatively affect the human nervous system. And this brilliantly illustrates exactly what scientists believe is happening inside the body. While they're still ironing out the exact chemical pathways, they've got two leading theories on how this neurotoxicity actually works. Theory 1 suggests that acrylamide directly attacks the structural proteins within our nerve cells, essentially breaking down their physical integrity from the inside out. Theory 2, on the other hand, proposes that the chemical inhibits the body's natural anti-inflammatory systems, the very systems designed to protect our nerve cells from damage in the first place. Either way you look at it, this chemical is actively compromising our neurological defense network.
To really wrap our heads around how serious this is, we have to look at the impact. Animal studies strongly suggest that long-term dietary exposure to acrylamide can crank up the risk of severe neurodegenerative diseases, things like dementia. But it doesn't just stop in the lab. In humans, dietary exposure is actively associated with neurodevelopmental disorders in children. So this isn't just some theoretical risk for older adults down the line, it can affect the very beginning of human development.
Just take a look at the specific findings from assistant professor Federica Laguzzi over at the Karolinska Institute in Sweden. Her research discovered a direct link between higher acrylamide intake in pregnant women and some highly concerning outcomes for their babies. We're talking about an increased risk of low birth weight, a smaller head circumference, and a shorter newborn length. This underscores exactly why the neurodevelopmental danger of this chemical matters so incredibly much. It's literally altering physical development from day one.
Section 2. The cancer connection.
Okay, so that brings us to the giant elephant in the room. Cancer. This is the classic parental warning, right? Don't eat the burnt bits, you're going to get cancer. Well, we've established the neurological dangers for sure, but we need to look at whether those black crumbs are actually carcinogen. Now, animal studies are definitively clear that acrylamide absolutely can be carcinogenic, but, and this is a big but, only in doses much higher than you would ever realistically find in human food. Meanwhile, the human studies, they remain stubbornly inconclusive. In fact, acrylamide has been officially classified as a probable human carcinogen for 30 years now. And yet, even after 3 decades of research, the evidence that it actually causes cancer in humans remains incredibly inconsistent.
Now, to be fair, the European Food Safety Authority has warned that it could increase cancer risks, particularly in kids. But the primary human data pointing to this, it comes from a single study out of the Netherlands. Those researchers found a higher risk of endometrial and ovarian cancers in women with higher acrylamide exposure, along with a slight association to kidney cancer. But here is the absolutely crucial point. These findings are completely unconfirmed by any other researchers. We simply do not know yet if what the Dutch scientists found is definitively correct across the broader population.
And that essentially brings us to the official global stance, which is perfectly summarized by this quote from the 2010 Joint Food and Agriculture Organization and World Health Organization Expert Committee on Food Additives. They explicitly stated, and I quote, "More long-term studies are needed before we can draw any conclusions about the link between acrylamide and cancer." So the cancer link, at least for right now, is kind of acting like a red herring. It's a possibility, sure, but it requires so much more scientific investigation before we can treat it as an absolute fact.
Section 3. How to protect yourself.
But hey, the good news is we can fight back. Even though the WHO says we need a lot more data on the cancer side of things, they still strongly support efforts to reduce acrylamide in our food purely because of those neurological risks we talked about earlier. So at the very beginning of the supply chain, agricultural researchers are attacking this problem at its absolute root. Remember how acrylamide forms? It comes from a substance called asparagine, which is just found naturally in plants. Wheat grain, especially when it's deprived of the nutrients it needs, accumulates way more asparagine than is necessary. So scientists are currently deploying resources to use gene editing techniques on wheat to stop this overaccumulation from happening in the first place. This ensures the raw ingredients are safer before they even leave the farm.
Now, what's really fascinating here is seeing how successful food producers have already been at the manufacturing level. Take a look at this case study of the Dutch breakfast cake, Ontbijt Koek. By simply tweaking their production methods, producers have been able to successfully remove 80% of the acrylamide that used to be in this popular product. 80%! It now contains only a fraction of the chemical it once did. It's a massive real-world success story that proves the food industry can absolutely adapt.
Okay, but what about in your own kitchen? Well, Dr. Fatima Saleh, an associate professor of medical laboratory sciences at Beirut Arab University, has this brilliant, incredibly simple hack to reduce acrylamide when you're cooking at home. Her method for making fries is literally just 2 steps. Step 1, cut the potatoes. Step 2, soak them in hot water for just 10 minutes before you cook them. That's the whole shebang.
And the result of that simple 10-minute hot water soak? It can slash the formation of acrylamide in those potatoes by as much as 90%. Literally 90%. That is a staggering reduction in a dangerous chemical, just from altering your prep time by a few minutes. It is a highly actionable, incredibly effective safeguard that you can use tonight. So, wrapping all of this up, with increased scientific interest, researchers are going to keep digging, and we will eventually uncover the exact relationship between acrylamide and human cancer. But honestly, for now, we don't need to wait for the cancer data to make smart choices. Protecting your brain and your nervous system from definitive neurotoxicity is reason enough. Avoiding those burnt sausages and taking a butter knife to scrape the black off your toast isn't just a silly childhood superstition anymore, it is a scientifically sound neurological safeguard.
Which leaves us with one final question. Armed with the reality of exactly what happens at 120 degrees Celsius, will you look at your next plate of fries or that slightly burnt piece of toast just a little bit differently? Science tells us that a little less heat or a quick hot water soak might just be the absolute best thing you can do for your brain today. Thanks so much for joining me on this explainer, and I hope this gives you some really great food for thought for your very next meal.